Hello, in this video I'll be talking about point-slope form. This is another form that you can use to find the equation of a linear function. It's helpful in writing an equation when the y-intercept is not known. So here is the equation: y minus y1 equals m times x minus x1. The reason some of the letters have a subscript of 1 is because those are the letters that we're going to plug numbers in for, whereas the y without the subscript and the x without the subscript are just going to stay as y and x. So the ones that are going to be changing, and I'll show you in an example, are this, this, and this. The y here and the x here are going to stay the same. So in this case, we're going to write an equation in point-slope form. So let's say we have a line that passes through this point, -3, 6, and has a slope of -5. What is an equation of a line? Well, here we don't know what the y-intercept is. So yesterday, or in the last video, we figured out that we could find the equation in slope-intercept form, but we had to do a little work to figure out what b is, right? We have to plug in for y, and then we have to plug in m, and we have to plug in x, and then we'll figure out what b is. It's not too time consuming, but what do we get? 15 plus b. So we know that b is going to equal -9 in this case. But an alternative to doing that is using point-slope form, and I find it useful and quick. So here's how we would use it. We would start with the formula, and remember, I recommend writing it down every time first before you plug in, just to get used to it, figure out what it is. So in this case, the y is going to stay the same. We're plugging in the values of the point here. So y1 is going to be 6. The slope m is -5. X stays as x, and then x1 is going to be -3. So what we have here, I'm going to change that to brackets because I need to put this -3 in parentheses, because we're going to end up subtracting a negative here. And so when that happens, as you should know by now, it means you're just adding. And so this is the equation of a line given a point and a slope. That's why it's called point-slope form. And it's nice to use when you don't have a y-intercept. Incidentally, you can figure out the y-intercept this way as well by just simplifying the equation and solving for y. So I'll just do that real quick. And notice what happens. Add 6 to both sides, and voila, you get the same y-intercept. Okay. So if you have a point and a slope and you want to find the equation of a line, I recommend using the point-slope form. So graphing using point-slope form. Well, again, you could, if you want, solve for y and just use slope-intercept form, and that would look like this. Y minus 1 equals 2/3 x minus 4/3, and then add 1 to both sides. So that would end up being what? -1 1/3 plus 1, so -1/3. So we could do that and then graph this way, but the problem is we have this fractional intercept, right? We have this fractional intercept, so when you go to graph -1/3, it's going to be in between grid lines, and then the slope to slope when you're in between grid lines is going to be a hassle. So sometimes graphing using point-slope form is helpful here. So what we can pull out from this is that x is 2, right? So here we have a coordinate, so 2, 1, because x1, y1, and then that's a point, and then the slope we know is 2/3. 2/3 equals m. And so that would be pretty easy to graph. So rather than searching around for -1/3 and then trying to slope off of that, it's going to be easier in this case to make a point at 2, 1 right here, and then slope 2/3 up 2/3. up 2 over 3. And as I said in the previous video, that could also mean down to left 3. Down to left 3. So you can see that these are connected in a straight line. So the purpose of graphing using point-slope form sometimes rather than slope-intercept form every time are in cases where you have a fractional y-intercept. Sorry, right here. Because it wouldn't make sense to graph a fraction on a grid that uses whole numbers. It would be hard to see what's going on. But you can see that it does cross at about -1/3 there. So we can feel confident that we graphed it in the right spot. Now let's move on to the next thing. So using 2 points to write an equation. So if we have a graph here, we need to locate 2 points that cross a grid line. So let's see what we can find. Looks like we cross right here and right here. Okay. So using these 2 points, we can find the slope. So it looks like it goes up 1, 2, 3, 4, and over 3. So we know the slope is 4/3. And we also know a point. We can use either one of these points. It looks like we have -3, -3, and also -6, -7. So let's just use this top one here. So we can write y minus -3 equals 4/3 times x minus -3. Let's make that a bracket. There we go. Again, we were using this point here, -3, -3. And we can simplify that if we want to make it look like slope-intercept form. So we have 4/3 x, and this was plus 3. So 4/3 times 3 is 4. And so that is the graph. And you can see that that's pretty correct. So the y-intercept was 1. The slope is 4/3. 1, 2, 3, 4. 1, 2, 3. So this is the equation in slope-intercept form, or this is it in point-slope form. And finally, using a table to write an equation. This is actually the exact same as the last example we did, except instead of looking at the graph to find the points, they're just listed for us. So we have 10, 640 and 30, 590, right? So whatever these numbers represent, we can figure out the slope and use point-slope form. So the slope, we can call this point 1 and this point 2. So remember, it is this. Common mistake here is to have put the y on the bottom, the x on the top, so make sure you remember that. One way to remember it is this is rise over run, and the y value is always the height, and the x value is the left and right movement. So we have y2, which we'll call 640 minus y1 over x2 minus x1. I didn't leave myself much room here, but it looks like we have 50 over -20, so we could call that an m of -5 over 2, or we could call it 5 over -2. You'll see that it won't really matter, because if you go down 5 and right 2, it's the same as going up 5 and left 2. The line will look the same. But our point was to make an equation, not to graph it, so we have the slope and we have a point, so we can use point-slope form, which again is this. So that'll start us off. So y minus, we could use any of these points, I'll just use the top one. 640 equals m, which we know is -5 over 2, times x minus x1, which is 10. Now remember, that's the equation in point-slope form. If we wanted it in y-intercept form or slope-intercept form, we could just solve for y. I just realized after doing this whole problem that I had written a couple of these numbers incorrectly, so it wouldn't actually be linear However, I'll fix that right up, and so we'll make sure that it is linear. So 640 to 590 to 540 to 490. There we go. Now it is linear. Thanks for watching.